Velocity and radius of revolving electron. We know that the radius is equal to 1 over 4 pi epsilon 0 e square over mv square. If r is equal to rn, then v will be equal to vn, and our expression will be rn is equal to 1 over 4 pi epsilon 0 e square over mvn square. And let this is our equation number 1. So what we want to do, we want to find the value of Vn square, and if we do that, we will write this Vn over here, and then Rn will go on the denominator, and we will have Vn square is equal to 1 over 4 pi epsilon 0 e square over mRn. Now, if we find the value of V, then we will take the square root on both sides, and we will get Vn is equal to e over square root of 4 pi epsilon 0 mRn. And let this is our equation number 2. From here we know that Vn square is equal to 1 over 4 pi epsilon 0 e square over m r to the power n. So basically we are getting this equation from here, and what we are going to do, we are going to take this m r n with v square, and if we do that, we have m r n Vn square is equal to e square over 4 pi epsilon 0. What I'm going to do, I'm going to write Vn square as Vn times Vn, and if I do that, I have mRn Vn times Vn is equal to e square over 4 pi epsilon 0. Now what I'm going to do, I'm going to keep my m Vn Rn together, and if I do that, I will write m Vn Rn times Vn is equal to e square over 4 pi epsilon 0. From the Bohr's postulate, we know that m Vn Rn is equal to nh over 2 pi. So basically what I'm doing, I'm going to substitute the value of m Vn Rn as nh over 2 pi in this expression, and if I do that, I will write nh over 2 pi times Vn is equal to e square over 4 pi epsilon 0. Then we can find the value of Vn as e square over 4 pi epsilon 0 1 over nh over 2 pi. So what we are doing, basically we are dividing both sides by nh over 2 pi, so this will be cancelled out, and on the right side we will get 1 over nh over 2 pi. Now what I'm going to do, I'm going to separate this n and bring that n up front. So if I do that, I will write the velocity of the moving electron Vn is equal to 1 over n e square over 4 pi epsilon 0 times 1 over h over 2 pi, and let this is our equation number 3. Now again, from the Bohr's postulate, we know that m Vn Rn is equal to nh over 2 pi, and what I'm going to do, I'm going to find the value of Rn, which will be Rn is equal to nh over 2 pi times 1 over m Vn. Now let's substitute the value of Vn from here to this equation, and if we do that, we will have Rn is equal to nh over 2 pi m, because I'm keeping everything together except Vn, and then for Vn we are writing this value, so we will write times 1 over n e square over 4 pi epsilon 0 over 1 over h over 2 pi. Now if we simplify further, we will get Rn is equal to nh over 2 pi m n times 4 pi epsilon 0 over e square times h over 2 pi. Let's simplify further, and if we do that, we will get Rn is equal to n square over m h over 2 pi whole square times 4 pi epsilon 0 over e square, and let this is our equation number 4. Now this is our equation number 4. If we simplify, we will get Rn is equal to n square over m, and h over 2 pi whole square is basically h square over 4 pi square times, and my this term, which is basically 4 pi epsilon 0 over e square. Now if we simplify further, we will get the term as Rn is equal to n square h square epsilon 0 over pi m e square. We want to find the radius for the first orbit, so if we do that, we will write for the first orbit n is equal to 1. Now let's substitute the value of n equals to 1 in this equation, and if we do that, we will write r1 is equal to 1 square h square epsilon 0 over pi m e square. If we simplify further, we will get r1 is equal to h square epsilon 0 over pi m e square. If we take r1 is equal to r0, then we will get R0 as this term, which is basically R0 is equal to h square epsilon 0 over pi me square, and this value of the radius is basically known as Bohr's radius, and this is how we will define the velocity and the radius of revolving electron.